The last remaining logic is the payment logic. So let's get to it. I will first go to the payments module and register the order here inside the type_rm module because we'll use a repository for it here. Now in the payments controller, I will create here a route from scratch, which I will call pay order. It will be a post route. I'll just quickly reload the window. So it will be a post route and it will receive an ID. The ID of the order that is being paid. I will then extract this ID here using the ID DTO, as we've learned. And inside this route, I would then return the namesake method from the payment service, which I am yet to create. I'll then hover the cursor over this pay order call, click here on quick fix and on declare method pay order. Now I'll go to the payment service and it generated for us the method signature. So I will delete this and then we can begin. But before beginning, we need to inject the repositories, of course. So I'll quickly go to the orders service just to copy this here very quickly. So I'll then declare a constructor and here inject a repository for order and for payment. Now just rename here and import these. And now we can actually begin. First, I will find in the database an order using this ID. And I'll also fetch it with its payment. Because first, if the order is not found, I'll then throw an exception. And I find it with its payment because if the payment exists, or in other words, if the order has already been paid, I will also throw an exception. In this case, a conflict exception. Then I will create a payment. Without DTO, because a payment does not need one. And then I will set this payment to the order. And I will change this order's status to awaiting shipment. And lastly, save this order once again. We are doing it like this because there are two steps necessary. First, to associate this order with this payment, and then change the order status to awaiting shipment. By doing it like this, we can perform both of these steps in a single operation, due to the cascade we set earlier. If we were to save the payment first, using its own repository, then we could have inconsistencies in the database if something went wrong. If this was the case, we would need to use a transaction, which we'll learn more about in the next lesson. A transaction basically encapsulates many operations in the database in such a way that if something goes wrong in the middle of this process, then everything is reverted back to avoid inconsistencies. But through the way we are doing it, we avoid having to use a transaction, which is quicker, safer, and simpler. I will then just put an async here, and then we are done. Also, just another quick commentary. Imagine if I wanted to pay for the order of another customer. Even though that may sound funny, it would be possible, which would be undesirable. In the extra module 1, Authentication and Authorization, we'll learn how to check if the person that is paying an order is indeed the order's owner. The same applies for when a person is updating an account. Only I should be able to update my own profile, don't you agree? Alright, let's now just test it. I'll then run the application again. And then, going back to Insomnia, I will then duplicate this folder and then call this new folder Payments. And here I will change the resource to Payments. And then delete these requests. And the create request, I will rename it to pay order and remove this body as it won't be necessary. And here use the path parameter ID as 1. And there we have the order that has been paid. If we check for it here again, we'll see that now its status is awaiting shipment, and now it has a payment. And if I try to pay for it again, then it will say order already paid. Excellent. Then just commit the changes. Implementing payment logic. In the next lesson, which will be the last one of the core module, we'll learn how to seed the database in order to have mocked data to make some tests. See you there.